Hello student, this the video is about the robotics structure with the different types of the joints. Through this the video we will learn what are the different types of the joint and the accordingly what are the different types of the robot configuration. In the unit 1 we learned the basic idea about this, but through this the unit 6 we will get the clear idea about the arm with the different joints. The robot assembly consists the different components such as the wrist, arm and the body. Actually the robot manipulator consists the two parts, which body with the arm. Body and the arm is used for the positioning of the object in the robot's work value, and the wrist assembly is used for the orientation of the objects. There are the several designs of the arms so that we get the flexibility in the movement within the work envelope. The simplest robot may be 2 or the 3 axis arms. This is the structure about the links with the joints. The robotic manipulator arm consists the several links making a chain, and the robotic link is the rigid component of the robot manipulator. This the robotic joints gives us the relative motion between the two links of the robots. Each joint or the axis provides a certain degree of freedom of the motion. Degree of freedom, that is called as the DOF in short. In the most of the cases, only 1 degree of freedom is associated with each joint. Each joint is connected to 2 links, an input link and the output link. Through this the sketch we get the idea. For this the joint 1, link 0 acts as an input link and link 1 is the output link from the joint 1. Whereas this the again link 1 now becomes the input link for this the joint 2, and link 2 becomes the output link for this the joint 2. This the joint link numbering scheme is the further followed for all joints and the links in the robotic systems. There are the different types of the manipulator as we get the motion. For the translational motion, we use the 2 types of the joints, linear joint and the orthogonal joint. And for the rotary motion, we have the rotational joints, twisting joint and the revolving joint. Translational motion. To get this the linear or the translational motion, as we know that we have the linear joint. This is the sketch for the linear joint. There is one, this is the input link and this will be output link. With the help of this, we get the in and out motion for the joint. Orthogonal joint, this is the orthogonal joint. For the rotational motion, we have the rotational joint, twisting joint and the revolving joint. This is the rotational joint R, this is the twisting joint T and this is the revolving joint V. In the robot manipulator, the joints are designated with some symbols such as for the linear joint we use the L, for the orthogonal joint we use the O symbol, for the rotational joints we use the R symbol, for twisting T, and for the revolving we use the V symbol. This separates body and the arm assembly from the wrist assembly using a colon. That means, for example, TLR colon TR. This the TLR assembly is for the body and the arm, and TR is for the wrist assembly. Now the polar coordinate with the help of this the different joints we get the different robot configuration, or we can say we get the different robot types also. In the polar coordinate system, the joints used are the TRL, that means twisting, rotational, uh, uh, and the linear. This is the twisting joint, this is the linear joint, and this is the revolving joint. Consists of the sliding arm L joint actuated relative to body, which can rotate about both the vertical axis and the horizontal R joint. In the cylindrical configuration, the TLO body arm assembly is used. TLO, that means twisting, linear, and the orthogonal joints are used. This the cylindrical body arm assembly consists of the vertical columns relative to which arm assembly is moved up or down. With the help of this the T joint, the arm assembly can be moved up and down, as well as the arm can be moved in and out relative to column. Cartesian coordinate system. In the Cartesian coordinate configuration, body with the arm assembly consists the LOO joints. L means linear, O orthogonal. It consists the three sliding joints, two of which are the orthogonal. This is the orthogonal and this is the linear joints. In the jointed arm robot, it uses the TRR body arm assembly, twisted, revolving. This is the twisted joint assembly. This is about the revolving joints. With the help of the twisted, base can be moved, and with the help of this the revolving, this the body or the arm can be moved. So there are the different sketches for the manipulator configuration, such as the TRT:R. This the TRT is for the body arm assembly and R is for the twisting wrist assembly. This the TRT is for the body and the arm assembly, and this the R is for the wrist. That means this the R type of the revolving joint is for the wrist assembly, and revolving twisting joints are used for the body and the arm assembly. In the another sketch, it uses PVR joints for the body and the arm, and TR joints are used for the wrist assembly. Now in this case, two revolving joints are used for the body with the arm assembly, and twisting joint is used for the wrist assembly. Now to get the joint motion, the different drive system we can use. We know that this the different drive system. One is the electric drive system, hydraulic drive system, and pneumatic drive system. Electric drive system uses the different electric motors such as DC, stepper motor, AC motors to actuate the individual joints. Nowadays, this the electric drive system more used in the today's robots. Hydraulic drive system. The hydraulic drive system uses the hydraulic piston and rotary vane actuators. Such hydraulic drive systems are the have the high power and lift capacity, so that such drive system for the joints are used when we need to lift the heavy materials. Pneumatic drive system. This drive system typically limited to smaller robots and simple material transfer applications, as it has the low power and lift capacity. So thank you students.